All right, let's look at the displacement and the total distance. All right, let's say a car or something is moving on a straight line, and say it goes forward for a while, and then it reverses, so goes backward for a while, and goes forward again, and then it says stops. All right. Then if you're interested in finding the displacement would be you look at the initial position, and then you look at the final position, and that's going to be the displacement, right? Right, so it could be negative. If you go backward more, then it could you would have a negative displacement. But however, if you're talking about a total distance traveled, so it's going to be always positive, and or it could be zero, I guess. And then the total distance would be, you would have to measure the distance here. So I'm going to call it D1, and then measures the distance here that where when it's going backward, and then we measure the distance going forward again. Let's call it D3. All right, so D1 plus D2 plus D3, D3 would be the total distance traveled. All right, let's say if you have a velocity function of this motion, so let's call it the v of t. So where v of t is the velocity function. All right, then if you want to find the displacement, then it would be simply integral from time a to time b of a velocity function with respect to t. Right? So that will be the displacement. But if you want the total distance, we would have to count the time it's going backward as a positive contribution. So what we need to do is integral from a to b. We're going to always count this velocity as a positive, so we put the absolute value around the velocity function. Then evaluate the integral. And this will give us the total distance, which is in this picture, d1 plus d2 plus d3. All right, so let's look at this concrete example. You have a velocity function, which is 3t minus 5. And we want to find the displacement and the total distance from t equals 0 through t equals 3. All right, so let's find the displacement. All right, displacement is going to be simply just an integral, all right, times 0 to time 3. Then you just have to integrate so 3t minus 5 with respect to t. All right. So this is going to be antiderivative of this is going to be 3 is just a number, and t squared over 2 minus 5t. And then you're going from 0 to 3. So if you plug in 3, 3 squared is 9, 9 times 3 is 27. Over 2 minus 3 times 5 is 15. 15 is actually same thing as 30 over 2, just to taking common denominator. And a minus, if you plug in 0, it's 0 minus 0. So you don't have to write that down. But this came out to be negative 3 halves. Right? So this would be the displacement. So it actually ended up going backward. All right. But if you want to find the total distance, then we have to actually take the absolute value of the velocity function. Alright, so let's do that. So first, First, we're going to look at the velocity function. So v of t is going to be, right, take the absolute value, right? So if you want to take the absolute value, so this is going to be a piecewise defined function. All right, it looks like when t equals 5 over 3, it becomes 0. So it's between, if, say, t is between 0 and 5 over 3. All right? And if t is between 0 and 5 over 3 and the velocity is negative, which means that the absolute value sign will actually negate it to make it positive. So that will be negative 3t. Negative 5 becomes positive 5. All right? And if t is between, say, actually maybe, it actually doesn't matter, but the 5/3 and the 3. And the velocity function is positive, so that means it's going forward. It's velocity v of t with the absolute value is actually exactly the same as v of t. So we have that. All right. So when you integrate, from 0 to 3 of absolute value of v of t dt, we would have to split it into two integrals. So first 0 to 5/3, and then you would have to finish from 5/3 to 3. All right. So first 0 to 5/3, you would have to have negative 3t plus 5 with respect to t. All right. Then the next one is just a 3t minus 5 with respect to t. All right. So let's evaluate this guy. So this is going to be, all right, antiderivative. So it's a negative 3 and t squared over 2 and plus 5t. All right. Then you're going from 0 to 5/3 and plus, then integral of antiderivative of 3t would be 3t squared over 2 minus 5t, and then you're going from 5/3 to 3. All right, so let's evaluate here. All right, so we plug in the top number first. So you have negative 3/2 is already there, and you have to square 5/3, so it's going to be 25 over 3 squared would be 9. Actually, we can simplify that, right? So 3 and 9 cancel out, so you have 3. All right, then you would have plus, right, 5 times 5/3, so it's a 25 over 3. All right, minus, if you plug in 0, it's 0, so I'm not going to write that down. All right, plus, all right, plugging 3, so it's going to be a 27 over 2 minus, plugging 3, 15, we've done it, so 15, I'm going to write it as 30 over 2. All right, then minus, all right, if you plug in, so you have 3 over 2, then we would have 5/3 squared, so it's going to be a 25 over 9 again, and a minus, all right, you have a 5 times 5, so it's a 25, and you have over 3. All right, so we have that. let's simplify. So you have the 3 and the 9 cancel out, so you have 3 there. All right, so this is going to be equal to, all right, so here you have negative 25 over 6. All right, so this is actually half of that guy. So you're going to have 25 over 6 from there. And here 27 over 2 minus 30 over 2. So it's going to be minus 3 over 2. All right, so we have that. And then we have subtract. So this is again the same thing. 25 over 6 minus 25 over 3 would be negative 25 over 6 with another negative sign. So it's going to be plus 25 over 6. All right. So this is going to be equal to. All right. So let's put the 25 over 6 and 25 over 6. So that will be 25 over 3, and actually maybe I should have kept it over 6. Maybe I'm gonna go back, sorry. All right, maybe I'll just do the common denominator, which would be 6. All right, so you have 25. All right, so negative 3 over 2 is same thing as negative 9 over 6, so it's going to be minus 9. Then you have another 25. So that's going to be 50 minus 9, so it's going to be 41 over 6. All right. So that's the total distance it traveled. All right. So again, it must be a positive because it was moving, and but the displacement could be negative. All right, again, displacement would be just the integral of the velocity function over whatever the time interval, and the total distance would be an integral of the absolute value of the velocity function. So don't forget the absolute value since you're looking for the total distance. All right, that's it. I hope that this was clear.